morning, everyone. So, this is Purnachandrarao, working as assistant professor. Today, we are going to discussing the topics of class, object, component, package diagram. Already, I discussed introduction to UML. So, what are the elements are there? What are the components are there? What are the notations are there? What are the different diagrams are there? And what is structural diagram? What is behavioral diagram? In the structural diagram, what are the structural diagram? What is meaning of structural? What is behavioral diagram? Behavioral diagram, dynamic approach already discussed, and the structural diagram is a static approach. So here today we are going to discussing class, object, component, and package. So all are statical diagrams. Now go for the class diagram. So the class is represented with a rectangle. Class is represented by the rectangle having a subdivision of three components. The first one is name, second one is attribute, and operations. So these are the things we are used. These are the elements we are used in this particular class. Okay. So it is represented with rectangles. I will show this diagram. And here there are three types of modularity that are described: the visual attributes and operations. So these are the plus, hash, and minus. Plus can be considered as public. So we can call as a prototype what you can call access specifiers. How we are going to provide access specifiers in this class diagram. So plus nothing but it is a public. Hash nothing but it is a protect, and private is nothing but a minus. So these are the operations we are used in this modifiers in the class diagram, right? And coming to this, some relations are there between the classes. So we have a association relation, and generalization and specialization, and dependencies, and one more the generalization and specialization. So these are the relationships you can use in the class diagram. Okay. Next one, the class diagram are essentially modified object aspects of the system. So here I am going to consider this diagram. So what is that? It is a rectangle behavior. What is that? It is having a rectangle. So this is a rectangle. It is having three components. So first one is name, next one attribute, the next one is operations. Next one is, so these are the three components we are used: name, attribute, and operations. The first one, shape, is a name. Shape is a name. Here the length is attribute, and go for the get length and set length is operations. Okay, in which plus means indicating what is the plus meaning of this. This is a public. So the access sphere is public, private, protection. Okay. So plus is indicate that. Now go for the class with the signatures. Signatures nothing but what is the data type it is. So we can mention here. So shape is a name, and length. Here length is integer. Length is an integer data type. And get length is a int is a integer, and again set length int. So it is a void, non-return type. So it is integer, but it is a non-return type. So this is class signature. So class with the signature. Okay. So these are the some relations are there: association, inheritance, realization, dependency, aggregation, and composition. So these are the relationships we are used in the class diagram. Now the simple thing we are used here, the inheritance and the composition and aggregation. So inheriting and composition with both are similar. Both are similar, but some kind of things can composition and aggregation are similar. So the aggregation maybe may not, aggregation will be one to many one to many relationship will be have there, one to many. So here composition means we have 0 to including of 0 and an exceptions. So maybe valid, not valid. So in that case also we can use composition. Inheritance means we are accessing the higher properties to lower property. So that is called as inheritance. So this is a symbol we can use, and this is composition. This is aggregation, one to many application, one to the 0 to any applications we can many. So relationship we can use it this. Okay, here aggregation can use one to many. So that is the thing, and go for yeah. So simple example is given here. This is one of the class. Animal is a parent class. Here the string name and string is a color. Name and color, these are the two attributes, and run is a operation. So here you use the public. It is a public. So this is entire called animal parent class. It is a animal parent class, and we have another class. We are having it dog, and here is a cat. So cat is another class. Okay, so animal and cat. So which are we are extracting the knowledge from this animal. So dog and cat. So here bark, and these are method children classes. So this is one children class, this is another class, and we are going to derive this dog will be multiple. Dog will be multiple, then it can be D1. So D1 is object name, so it is runs. So this is object of the children class. So this is representing of object. So this is the diagram. So we are inheriting of some properties from the parent class to parent class. We can use inheritance symbol here. So this is the thing. So this is the aggregation symbol from one to many applications. We can use it. One to many, one to star. Many objectives we can create it. One to star. Now go for objective diagram. Objective is a instance of the class. Object is nothing but instance of the class. The relation has been point of in a time, and they provide a snapshot actual objects and their attributes within the system. So it is similar to class, but it is a runtime entity. Object is nothing but it is a runtime entity. So we can use this diagram. The notations will be here. The class name and classifier name and attribute. Just simple. The object, what is the object name and what is the classifier we are used. So similarly, I will show this. So D1 is a objective name. So I will show here the example of the students. The class students are linked to the object of the classes of the class college. Now the simple diagram here. So this is class A college. We are having what is that number of the students 1200. City, so values city A, number of the department 9, and faculty strength 120. This is a college level. So in that we used one more objective, the student 3030, that is, this is objective name, and his classifier name is student. Classifier name is student. Okay, so here the class name is A and department of CSC and year is 4. So this is one of the objective diagram, and similarly one of the object name, he is student 3030 is a name, and he is a student. Classifier name is the student. It is having a data name B and department CSC. Yeah, so this is the objective diagram can be represented. So this is association between college and student, college and student. Okay. So here the component diagram. So component means I already explained the physical or logical component of the system. This is a physical and logical component of the system, either libraries, executable, and the reusability of the software modules. And that means what are the components, what are the elements you are used to developing of an application is called as a component. The basically that is how you can understand it. So what is the application you have developed, that is one of the component. So either libraries and executables are reusability of software modules. Reusability of the software modules. So these are the means different text boxes, labels, and buttons. So these are the things we are used combined into one form that is called as a component. So component can be represented. This is a symbol, square box. So this again internal one square box, and we have two square boxes. This is the notation for the, this is the notation for the component. So here we are going to interaction between the components. We have an interface. We are required some interface. So off circle, you can use it off circle. So this is called an interface off circle. With this is can be represented with interface. So interface small circle and semicircle. So this is small circle or semicircle. So this is indicating between the two components. Between we have a two component, between we have a interface, then we can use this symbols. Similarly, dependencies. We have used some dependencies. So this is the dependency symbol. So dependency component using a dashed arrow. So this is called a dashed arrow. So this is a dependency between these two. One component is depending on this component. So that is the arrow, dashed arrow can be used here. And we go for the port. The port is indicating with this here the component having some port. We are going to communicating between the one component to, this is the physical component, this is the logical component, this is the physical component, right? This is the logical component, this is the logical component, this is the logical component, this is called the physical component. Okay, the physical component. Now between these two we can interaction by using of node, the node. So this is a diagram, we can use it, right? So here the port indicate the square bracket with the component, right? So clear the component diagram, what are the components are there. So some example of this component diagram is go for this diagram. Go for this diagram. We have two components are there. The first one, not three components are there. So the first one, web store, is a one component, is a one subsystem, it is also one of the component, and another subsystem is web store. It is web store is a one component, and warehouse is another component, and accounting is another component. So these are the physical components: web store, warehouse, and account. So these are the different physical components, in which also have some other components are there. So in the internal structures, we have a search engine is a one component, and shopping cart is another component, authentication is another component. So these are the three components are included in this particular web store component. And similarly, web house having of one component, inventory is one of the component. And go for accounting, have three components are there. So internal structure means internal structure of this, ordering of the one component, another customer is another component, and account is another component. Okay, so these are three components having in this account. One component is having in this warehouse. As a web store having of three components. One is search engine, shopping cart, and authentication. So now we have some ports here indicating the one port is another port is another port. Okay, now the product search. So we are going to search an element from the search engine, search on element from the search engine. So this is diagram, we can use it. Similarly, online shopping also, online shopping, we are going to communicating the shopping cart, we have a port number, we have a port. So user sessions, so authentication session also there, so the user is valid or not, so we can identify through a port number, to a port. So we required all are the ports. Through ports only, we are going to communicating with the web store. We are going to communicate with the web store, right? Similarly, now here we are going to this is one port, and this is one port, and this is another port. We are going to communicate with two ports. Here also two, here is one port, this is another port, this is one port, is another port. We are going to communicate with the user session to authentication, online shopping to search cart, product search to search engine. So these are two ports, we can use it. And between these shopping cart to and authentication, we have an interface. So here user sessions, we are use it. Okay, so this is the interface between the shopping cart to authentication. So this is user session, so authentication, so user is valid or not, and everything will be so communicating you require. So that's why you are using some interface between the shopping cart and authentication. And after that, we go for warehouse. Warehouse is one of the components. Now here the inventory. So in the warehouse have several the products are there. So that is, I'm not discussing here what are the products are there. So here some inventories are there. So now we are going to communicating with this such inventory to this internal structure of the warehouse. We have some ports. Now we are going to communicating with these two. So because all are network oriented, all are network online means all are network oriented. Network means we should be use the port numbers. Port must be used for communicating between the internal physical and the logical structures. Now here now we are going to communicating between these two some of circle. So this is some in dependency we are use some dotted with arrow, added with arrow. This warehouse to account some what is that? Some relationship also there. And here the internal structure, we have order and customer and account having of three components. And again we have some interface between these order and customer. We have one interface that is called the managing customers, and we have customers and account. We have one more interface like managing the account. This is the structure of this. And similarly, now we are going to communicating between these web store to here and web store to here. We have another port. This is another port. We are between these two. We are communicating this. So this is called customer managing the customers from between these two one port. So here also one port. Here also one port. This is the web store port, and which is communicating with the accounting port. So this is managing of order from this to supporting this. Okay, and setting of inventory, this is one port and this port. So warehouse to web store, we have two ports, we are communicating here. Okay, so this is actual components we are going to discuss. So this components, so we have three components. The major these are physical components, web store and warehouse and accounts. So these are some logical components. Now in between also some components are there. Now how they are interacting. So through port number and interfaces, how this is a diagram we are going to discuss it here. Now go for the package diagrams. In the package diagram, the package diagram means package relationship between the various packages, namespaces, including the system. Like for example, Java, io star star. So it is one of the package name. Java.io star input output, all the elements, what are the functionalities are there, so everything will be included in the Java. So that is we are going to creating the some package. So here we are going to discuss some packages whenever we are utilizing of already pre-existing methods. We are using of pre-existing methods we are going to call. So what we will do, what are the, we can pre-build some methodologies. We are using some functionalities. Keep on one package. Now we are going to utilizing in our program. So for that we can use this package diagram. So so the package can be represented here. So this is the package diagram. So the package name is tab on inside the rectangle package name, and package is a rectangle small tab in the top, and dotted arrow dependencies. Dotted arrow is a dependency, and one package depend on another. If another word consider fields changing in the files. So here just a simple what happened here. So two packages are there. The bank is a one package and UI is your interface is another package. Now we are going to use that some dependency of this arrow indicating that. So now the package name here com.a bus business business SS is one of the package like java.io.star like that. So here the one package name, so in which we have several packages are there. We have in which also several packages. Account is one package, ordering is another package, and shipping is another package. So these are the some packages are there. In between some dependencies are included. So the account is dependent on order, and shipping is depend on the order. So all will be depend on this order package. Similar way, one more package is we are used here data management. We are using of data management is another package here. So this is one of the package in which data management is one package, in which we have two packages are included, ordering and shipping. Ordering and shipping, these are two packages are including. So we are accessing from the above to here. So ordering and managing this we have some dependencies. The shipping is depending on this order. So on a similar way, order is depending on this this order means business order, and similarly this order management is depending on this order. So this vice versa will be applicable here. Also vice versa will be applicable. Shipping will be applicable. So all will be we are accessing from this package name. So this is called as possible forcing changes in the fits. So this is a package diagram which how package can be included, how can be dependencies will be used. So that will be discussed in this diagram so far. The example, another package diagram here. Now the name owing here name owning package name package. So Java utility.date. So this is one of the packages. So package where utilize Java, in which utility is another package, and this date you can accessing it. So for that simple diagram you are here you have discussed. So Java is a one package, and in which you have a utility is another package, and in which you have a date package. So it can be represented in this model. Similar way. So this is another Java utility data. So Java utility dot data. So this is fully qualified. So this is so this is nested with the caption in the tab. So here what I'm caption the package body. Similarly full file. So this is entire package. This is directly we can use in our project. So this is a way of representing of the package. So this is very easy to understand for package notations. So now the example of another when importing something, we are going to importing from one package to another package. So that is, you can use this aggregate or that dependency symbol. You can use some dependency symbol. So here the symbol is import. Access one package to another package. Import means one package import functionality to another package. That is called as an import. And go for what is that access. So one package to another package. This is package 1, this is package 2. Okay, this is one package, this is another package. Another package. Between these two we have some dependency. We can have some dependency. So what is the meaning of access? One package requires requires help from one function to another package. So this is a simple diagram. You can use it to understand. So we are looking into this picture. Now one more diagram for the packages. Here the modeling a complex grouping. So the package diagram has depict a hierarchical relationship grouping between the packages and other package, object, package, representation. So here is a layering structure. Layering structure is one of the example of the packages here. So this is entirely called layered application. This is a layered application in which we have one packages are there 1, 2, 3, 4, 5, 6, 7, 8, 9 packages are there. In the presentation layer, users layer to presentation layer. So presentation layer having of two layer packages. User interface is one of them, and next one is presentation logic. Similarly, service layer having the user interface and presentation logic, and extension layer also the extension system. And go for here the business layer having of three packages: the application of facade and business workflow and business components and business editors. So these are the packages we are used. So we are dependency symbol we are used here. And similarly, and cross cutting is one of the package in which several packages are security. Next one operate journal management to next one communication. So these are the three different packages are included in this cross cutting. This is in this cross cutting. Coming to the data layer having of data access, service agent. So these are two packages we are used here. So so outside of this data layer, we have data sources and external sources. Data sources we are getting it dependency, and external sources we are going to dependency. We have a dependency. We are between dependency between this data layer to cross-cutting layer, dependency between the business layer to the customer cutting cross-cutting layer. Similarly, we have a dependency between presentation layer to cross-cutting layer. Similarly, service layer to cross-cutting layer we have some dependency have, and external system have a dependency between the service layer to this is a diagram where this is a way of representing of the packages between package in between have some packages are included. So this is a way of representing packages and some relations. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.